Här under kvällen. Welcome.
I understood about 3 words, and I think my name was in there.
Yeah.
Men jeg lærer norsk nå. Så jeg skal snakke sakte. I'm just kidding, I won't do the whole thing in Norwegian. But just so you know, my plan is that next year I'll be able to do this in Norwegian, and then I'll have to learn Swedish. So the next year after that, I'll learn Swedish.
Good stuff.
So you have something to wait for. Of course, those of you who don't know me, you just say, what the hell is he talking about? Why would I care? So just a little bit about me, because that's my favorite subject. My name is Osherove. You can find me on Twitter. And I put a guitar here. I started working in Bouvet in September. I wrote a book called The Art of Unit Testing. It had examples in .NET, but it also applies. A lot of people from Java, the Ruby world, and JavaScript world find it also pretty useful. I'm currently writing a 2nd edition of that book, and some of the things we'll talk here are the things I'm going to include in the 2nd edition of the book. I'm also writing another book for team leaders. So if anyone has ever had to be a team leader at a team and had no idea what they're supposed to do now, you can feel free to contact me and I'll tell you what you're supposed to do as a team leader. What's your role? Because that's something that I had to face. I never knew what I was supposed to do. So I teach new team leaders how to become good team leaders, and management techniques and listening to people and all the psychology blah blah stuff. That's actually important, it seems. And unit testing is a very technical aspect of people aspect. So a lot of the things we're going to talk about today are about how people react to our code when they see it. But for me to be able to adjust today's presentation to your knowledge, just a little bit of questionnaire so I can adapt. So I started by asking how many people here did .NET. So raise your hand if you do or know some .NET. Okay, what about JavaScript? Ruby? Java? Okay, so most people here are coming from the Java world. So this should be no problem for you guys to read from Java and JavaScript world. Most of the examples here are going to be in C#. If you have any Java specific questions, feel free to ask, because I basically teach 3 and 5 day courses about unit testing and TDD practices in Java, JavaScript, Ruby, C#. So feel free to ask whatever you need. Okay. So a lot of the stuff that you're going to hear, you can actually get a lot more for free. I just record videos and I upload them. I don't have any kind of thing where everyone has to pay me for anything that they see me do. So this is recorded, and I'm going to upload this talk as well and just put it at artofunittesting.com. So you can see many variations and many reviews of code that I do on this site. If you go there, you'll find a lot of videos on YouTube as well. And if you ever want to contact me about anything that you see here, feel free to just email me. Okay, so when I started writing software about 15 years ago, I had no idea what unit testing was. I actually started in VB5, moved on to VB6, and then I discovered that there was a framework called VB Unit, which is the first unit test framework I've ever used. That was more than 10 years ago. Then I moved to C#, I did C++, Java, and Ruby in the last couple of years. And what I found is that most people, when they try to write unit tests, including me, have no idea how to make the tests actually work in their benefit. So a lot of times people start writing unit tests and do stuff in TDD, but they do it in a way that actually inhibits progress. So 3-4 months after they start writing the tests start fighting back. So instead of the tests helping you, at some point they actually start costing you a lot of time, a lot of money, and you end up maybe just deleting the test at some point. So this talk is going to be about making tests that actually last a long time, that contain 3 values: readability, maintainability, and trustworthiness. And these values work together. If you only break one of them, you actually break the others as well. If you cannot read the tests, it doesn't really matter that they're maintainable. It doesn't really matter that you trust the results. If you can't read them, you can't really maintain them, and you won't understand why something is failing or not. If you don't trust the test, if you run the test and they pass, and you still debug the code just in case, I'm sure none of you have ever done that, that means you don't trust the test, so you actually don't save any time by running them, if you keep having to run the code manually as well. One of the nice things about tests is if you truly trust the results, you can run them automatically, get feedback, and actually move on. But we'll look at tests that have a trust problem, and how to make sure that we can actually trust them later. And maintainability, that's the aspect that costs us the most usually. We start writing tests, and it looks good for the first couple of weeks. How many people here have written a unit test in their life? Just to make sure. Okay, that's good. So we start writing a test, and after a couple of weeks, it becomes more and more tests, and after a couple of months, it becomes more and more difficult to write new code and new tests. And at some point, you just either give up or you disregard the results from the test. Has anyone ever seen tests that fail and said, that's okay, it's gonna be okay, I don't mind? Has anyone ever said about a red test, yeah, you know it fails, but I have better things to do than to fix that? If it fails every 3rd time, then it's probably okay. Has anyone ever said that? If it fails, but I know it's a database problem, then I know it's okay. Has anyone ever said that? So that kind of stuff is the stuff that we need to avoid. Because if we don't, the culture that we create is that we don't trust the test, we don't trust the results of them. And then when they actually try to tell us something important, we actually don't listen. And we can go on 3 months until we realize that the test was actually telling the truth. So first of all, we have to trust our tests. The first thing to do to trust your test is to separate unit tests from integration tests. I'm gonna explain what unit tests and integration tests are. A unit test, a good unit test to me, is a test that is readable, maintainable, that I can trust, but technically it is consistent. That means it always returns the same result, no matter how many times I run it. It is fast, so it doesn't, I don't have to wait a long time to get results. Fast, half a second is not fast, okay? 0.1 seconds starts to be fast, because if you multiply it by thousands of tests, half a second is really not very fast. But it's not only consistent, it's not only fast, it also has, it's also automatic. I don't do things manually, so I can run the tests, and 3 months from now, anyone in my team can run the test that I wrote, and I can run everyone else's tests. A good test is also isolated. That means that it doesn't affect other tests around it. I can run the tests in any order, and I still get the same effect. But what makes it a unit test is that it doesn't have any dependencies that it cannot control. So if I'm using the file system, I don't consider it a unit test. If I'm using a database, I don't think it's a unit test. If I'm using a random number generator, I don't think it's a unit test, because I don't have control of a random number generator. Now also, if I'm using a random number generator, I don't think it's a unit test because it's not consistent. Every time I run the test, I get a different number. So every time I run it, it's actually a different test. So a random number generator might have its place in its test, but it's not in the unit test folder, and it's not in the unit test project. I would have an integration test project and a unit test project for any production code project that I would write. So everything that answers all these things, that doesn't have dependencies on the file system, on threads, on randoms, etc., on the date time, will be in the unit test folder. Everything else will be in the integration test folder. So I don't mind if it runs fast, but if it touches the file system, it's an integration test. But why do I actually want to separate these things? I don't just want things to I don't just want to know what something is. Why is it important for me to know what it is? Because if I only have unit tests in one folder, and I know they're unit tests, then they're consistent. When I get the latest version of the code and I run all these tests, what's supposed to happen? That they should all be green. Green. There should be a safe green zone. When I get the latest version of the code, it always passes. Always. And if something there is red, I should truly be concerned. Okay? So that gives me trust. At least that area of the tests should always be passing. And if those tests are red, then something is truly wrong. Now, for the integration tests, because they're in a separate project, then I know that these things will need configuration and maybe some connection strings or whatever. And I know that for them there is less trust than I have in the unit tests. But at least I have this safe green zone somewhere in the project that I can run and I know that it actually works. And that's one of the ways to gain trust, is to know that something truly doesn't have any dependency problems. It should be passing. And if it's not, then there's truly something wrong. Now, I want to introduce another concept that a lot of people don't do. If you want your tests to be good, it doesn't just matter that you know how to write good tests. It matters that you teach others how to write good tests. Again, it's a people problem. All software problems are people problems. Now, the best way to teach other people how to write good tests is to pair with them, pair programming. But since most people don't do it, because when you tell a manager pair programming, two people on the same machine at the same time, most managers would ask, other than save me on hardware, how does this actually help? And the truth is that it's really hard to quantify how much it helps. Over time, you can see the benefits. So most people don't pair program, unfortunately. But you can do code reviews. Most people do start doing code reviews. But instead of just code reviews, I want you to do test reviews. One of the things that I did in a company, in the previous company, is that we had a code quality issue. So what I asked as a team leader is that from the next 2 weeks, all code that gets checked into source control gets reviewed. And even if it's one line of code, including all the tests, and it helped the quality tremendously, even though it was a bottleneck. And we made sure that people switch and people learn how to review other people's code. So after 2 weeks, it's no longer a bottleneck issue. But the reviewing other people's tests was actually a great way to teach them how to write tests well. Because just because you know, it doesn't mean that everyone else knows what you have in your head. So reviewing and talking to people is the best way. If you review other people's code through the test, you also get some other benefits. The code review can be up to 10 times quicker. Now, 10 times is just my own personal feeling. I don't have scientific data. It's just my own personal anecdotal information from my own experience. Because when you look at tests, what you see is what the programmer actually intended to do. If the test has a good name, you can realize that the programmer got the requirement wrong without even looking at the code. Instead of reading 50 lines of code and saying, aha, you delete the user only after you see this. Oh, no, that's not what's supposed to happen. The problem is that it took you 10 minutes to get to that realization. With the unit tests, you should see a use case in the system from beginning to end and what's supposed to happen. A small use case, but still a use case. Then you can drill into the real code when you need to. So if you really want things to change, if you want people to adopt unit testing, do code reviews and do test reviews. And one of the things you should look for in the test reviews is separation of integration from unit tests. If you want to trust tests, you should make sure that code coverage actually makes sense. A lot of companies treat code coverage as something to strive to. So ignore that for a second. How much percentage of code coverage is good? Any ideas?
It depends on what you are testing. If it is a server system, perhaps, or a GUI.
Okay.
I mean, to test where the button
Okay, so
layout
service
works.
system, a server system,
Yeah.
how much code coverage should it have?
90%.
90%.
Well, we got my last company around 80 was a very high
80
number.
was pretty high, okay.
Yeah, it was very high.
Okay.
You
So
don't test the interfaces and
what about 99%? What about 100? Can you get 100?
yeah, but is it worth it?
Is it worth
In
it?
interfaces, do you test?
If I'm the CEO of a company and I tell all the coders to have 100% code coverage, will I get it?
Yes.
Of course.
But you
Will
won't
I
get
get good unit tests?
Nope.
Nope.
You won't get any certs.
Probably no certs. I'll get exactly what I asked for, code coverage, but it doesn't mean that the code is actually tested. So this is the important thing, that when you treat code coverage as a metric, you have to not see it on its own, because if I have 100% code coverage, it doesn't mean anything. If I have 10% code coverage, it definitely means something. It means I'm missing some tests. But if I have 100% code coverage, it doesn't mean anything unless I do test reviews, unless I know that the tests are good. So if I have good tests and 100% code coverage, then I know I'm in a good place. 100% code coverage without code reviews does not mean anything, because you don't know what people were attempting to do. So one of the things that I do when I do code reviews is that I sit with the person, and instead of just running a coverage tool like Clover or something like that, I go to one of the logic pieces that are being tested, and I say, okay, what happens if I change this true to false? And I run all the tests. Will something fail? And the answer is probably, well, you look at the face of the person, and that's all that matters. Because if the person looks and says, yeah, something's going to fail, they're absolutely sure, you can tell that they were writing things in a test-driven way. If the person is like, they're not sure, you can pretty much tell that they wrote the tests after. So it's more of a coverage thing instead of a test-driven thing. Now, it's not to blame people, it's just to figure out what is the current culture in your organization, in your team. Are people actually doing what they're saying they're doing? How do people treat the specific task? And for me, it's also, if I review someone's code and I do it this way, like I actually look at the code and I care about specific little things, then it shows that I actually care about the code that someone wrote. It's not just like a tool, oh, the indentation does not match exactly 4 tabs by my tool that reviews you, so something's wrong. It's actually me going in and looking at the details and understanding what the person was trying to do, and mentoring and coaching someone. So code coverage is just a way to make sure. It's just another viewpoint, but it's not everything. You want to trust your tests, you should avoid any logic in your tests. Logic is anything that could be, that has, for example, flow control. So if you have loops or ifs or switches, that's an example of logic. And the reason you don't want to have logic like this in your tests is why? Any ideas?
Suppose keys is empty.
Yeah, so what's the underlying
Then
assumption?
Then we want to find if it's the assert policy is correct or not, because we didn't even check for it.
So the logic, so what I'm trying to say is that if you have logic and your tests are supposed to,
You would actually need a test for a test.
you would need a test for your test because you have logic, so you might have a bug in the logic.
Exactly.
That's a good point. How would you test how would you know that a test for your test is good? You could write a test for it,
Just an example.
etc. So it's a very recursive thing. Now, that's one of the reasons to avoid logic. If your test is going to be with your software from now until the software is dead, that's probably 5 or 10 years this test has to live. Over 5 or 10 years, the probability of logic actually having a bug in your test is pretty high. So avoid logic. If you have logic, a lot of times it means that you're trying to test multiple things anyway. Or you're trying to test something with an input that is already too complicated. Now, for example, do I really need the loop if I know I have exactly 2 keys? I can just do 2 asserts? Probably not. So a test should be as dumb as possible in terms of statements, a unit test. Just statement, 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 assert, assert. No ifs, no switches, no loops, because that could actually introduce bugs. Now, I want us to take this test as an example of other things that could go wrong in a test. Not necessarily trust issues, but there are also some more issues here. Now, to review other people's tests, I usually tell the person, when you write the test, I want you to assume that the person who's going to read your test is a serial killer that knows where you live. Don't piss them off. So, for example, if they have to ask unnecessary questions, imagine that they will just take an axe and go to your house and ask the question. So don't make them ask unnecessary questions, because you won't be there. You will already leave the company when they read this test. So if you are the serial killer looking at this test, do you have any special questions about this test, things that you are not sure about? I would love to hear them, yes.
What is it that is supposed to be tested?
What's supposed to be tested? The name is probably not good enough because the name doesn't tell us what's supposed to happen. It says select constructor with 2 parameters. That's a very common naming convention where you actually hide what's supposed to happen. We do have the thing that's being tested. We do have the scenario, but which one of these asserts is the important one? Nobody knows. I guess we'll take our axe and go to the person's house and ask them, what were you trying to do with this test? Anything else that jumps out that you don't like? Otherwise, this test is perfect.
No, the application logic is completely hidden.
The application logic is hidden. Well, we're not domain experts, so we don't even care what the domain is.
Okay, there's a constructor in there somewhere.
There is a constructor in there.
I can't even read the
Yeah, but
the
assuming that you know
lines.
the domain, it would be readable to you. But even if you don't know the domain, you should have some problems with this test. The name, for example, is an example of something that you don't need to know the domain to say something's missing here. Yeah.
You're asserting a lot also.
Sorry?
You're doing a lot of assertions.
A lot of assertions, and that's a problem?
Yeah, depending on your testing. So, I mean, that one is very general.
Yeah.
So if you want to know that you have 2 constructors, maybe you just need to test that you actually got something in return from the get constructor that has 2. You don't need to test
That's
that.
more of a domain knowledge, but the saying that multiple asserts might have something wrong there is a good assumption. It's okay to have multiple asserts, but only if they're on the same object, because if you have multiple asserts on different objects, you're probably testing multiple things. And the problem with asserting multiple different things in one test are that if this assert fails, it actually throws an exception. So all the code below it will never execute. So you'll know this failed, but you don't know what's the status of these things. And if you care about them, what you're going to do is you're going to start commenting this out and seeing what happens. Or worse, you're going to fix this and then find out these failed. And then you won't know if they failed because you fixed it or they always failed. Then you start fixing one after the other. And that's called assertion roulette in the XUnit test patterns book. And it's a pretty good name. So usually multiple asserts, I look at them very closely and I see if they're on multiple objects, probably not a good idea. Here they're on the same object.
So one is that apart from that method name, in comments we can give a brief discussion that what this test is going to be
Yeah.
about.
We can put a comment on this test name. But the problem with comments on test names is that when you have 2,000 tests and they fail, the only things you're going to see in the log are the names of the test. If the name of the test is good enough, you won't have to go to the code and read the comment. It's going to save you some time. Okay, so comments, they're not going to be your friend when it's 2 a.m. in the morning and the build fails and you have 30 failing tests out of 30,000. You look at the test names, if they're good enough, you'll know where the problem is without even needing to read the test code, usually.
And there's no rule stating that the comment will be correct.
There is no rule stating the test name will be correct too, by the way.
No,
But I don't know, sometimes people, I don't know why, but for me, it's more likely that the test name will be correct than a comment. I don't know, because people feel that test names, the method names are more important than comments. Comments, you know, once a comment is there, no one will ever remove it or change it. It's just concrete. Anything else that you're bothered with this test? Yeah.
Well, it's a big test for me.
This is a big test. Well, I've seen bigger,
Yeah.
but
I saw
and
one-
you can see it fits on one screen, right?
Once I saw a test that was 2,000 rows.
Well, a test for 2,000 rows is not a test. That's a program.
Maybe you could put arrange back assert.
We can put a range act assert, but if we do that, it's already not readable.
Yeah,
Well, I'll give you an example. I'm a serial killer, and I look at this code. Say, new injection parameter, 37. Why 37? What's so important about 37? It must be important, or they wouldn't have used exactly this number. Now, of course, the programmer who wrote this is not there anymore, so I don't. So I'm just going to use it in my tests too, because it's probably important. So I'm going to write my test with 37 from now on, whenever I need to do this, because I don't know what it means. So unknown magic numbers have a tendency to procreate. And soon you're going to have hundreds of these tests with 37 scattered all over your test project. And no one will know why. Of course, you're going to look for 37, you're going to find 300 of these. And they're all just, no one knows. It's like the person going to a line, so why are you standing in line? Nobody knows, but I saw 30 people standing in line. I stand in line too. Nobody knows why. So magic numbers, not a good idea. So it's always better to use hard-coded, very simplistic numbers, or just use variable names that explain that something is not important. Some number here would be better. But you can see ABC, I can tell it's not important, because it doesn't say B, D, Z, it says ABC. It's like the first three letters. Our brain is designed to see these patterns that are the first thing that makes sense. So if I used 1 here, it probably wouldn't be interesting. If I was using 2, it would be interesting.
But it would not be 1, 2, it would be 12.
It could be 12, but 12 is interesting. 1 is not. Now, sometimes, there are times where 1 would be interesting. And that's where you actually use a variable name to say some number. So readability issues abound with this test. There's logic here that creates trust issues. Other than that, it's great. So here's a different example of logic hidden deep in the bowels of your tests. This is not actually a test. This is a helper method for the tests. What it does is it's creating a fake HTTP context. And it actually uses an isolation framework or a mocking framework called mock, M-O-Q, to return specific things from the properties of that object. So when someone calls a request application path, I want you to return whatever is in the parameters here. Now the logic problem here is that we have all these ifs. So sometimes people will use custom ports, sometimes they won't. And again, the problem is that if there is one thing worse than having logic in your tests, is having logic in the helper methods for your tests. Because if you thought no one ever looked at the test and assumed that the test has a bug, no one will never assume that the helper methods for the test have a bug. And this gets compounded because it's used by multiple tests. So if we can get rid of all these ifs, it's much better. Now there's a simple way to get rid of it. We create a hard-coded get HTTP context with app path. Get HTTP context with port. We do overloads of the same method. So we never need ifs statements inside. That would solve our problem pretty nicely. And again, if there are any questions, feel free to raise your hands and ask.
How would you say the usage of if statement with the case?
Sorry?
With the case, can we use the case also apart from switch?
Yes, the case?
Yeah, case.
I would say that case is an example of a switch statement.
Yeah.
A case is an if statement that's just very long. So a case also could have a bug. You can have the wrong casing, right? So I wouldn't use cases as well. It's also harder to read, it's harder to maintain. It should be a simple thing. If you have a case, you're probably testing more than one thing too. But here, again, if I don't have to use case, I won't. Because it's test code. It should be as simple and dumb as possible. That's very important. Because if I have a bug here, I don't have any tests for this stuff. If I have a bug here, it's very, very likely that I'm never going to see it until it's way too late and I have 30 things that I have to fix. So sometimes, if you have to have logic in your helper code, you write test for the test helper code. Sometimes you have to do that. Here's another common thing that I see a lot of people do. You want to assert that some result was gotten, but the result that you want to assert against is generated dynamically. So imagine that you wrote a test that sends in a number and expects that number as a string, okay? But you use the random number generator. So you don't know what number you're going to input, but you also have to calculate what number you're supposed to get back. Now the calculation you're going to do is going to be the same calculation that's actually in production code. And you're going to do it in your test. So if you have a bug in the way you think you should parse the number, you're repeating the bug in the test code as well. So the bug will never be found. So as an example here, let's assume that I'm supposed to call create message and I give it user and password, and I should get a string with a comma between the user and the password. Now, my mistake is that I'm asserting that I'm getting back the user plus this plus password instead of using a hard-coded string. I know what's supposed to be the end result, so nothing is stopping me. In fact, it's much better if I assert that there is a specific string that looks exactly like this that I get from some result, from create message. And then I don't care how the string was created. And if it actually has a bug, it won't be in my test, so my test will actually find it. Because if my bug is that I'm missing a space just before the comma, and I'm missing the space both in the test and in the production code, then my test will never find it. But if I have a string that looks exactly like user, space, comma, password, then I will find it. It's very easy that way. So unit tests should be simple and hard-coded. Don't generate the expected things that you are asserting against dynamically, because you're likely repeating production code if you're doing that. And if you're not, you just have pieces of logic that could have a bug, even if it's not production code, you want your unit test to be consistent, so never use things that change. Don't use the current date time, don't use random numbers, don't use the environment tick count if you need it, don't use threads. Unit tests should run in the same thread, they should run in a single process, and should be able to run linearly. Now, there are some frameworks that allow you to run unit tests in parallel. It depends on the test framework that you're using, whether that's actually possible or not. Because in some frameworks, in .NET, for example, they share, the unit tests all share the same variables as they run. But in some other frameworks, for each test, a new class is created in memory, and so there is pure isolation between them. So it's very important to, if you ever plan to run your tests in parallel, to check very closely how the framework actually executes your tests, and to look at the documentation. Here's an example of an amazingly beautiful, disgusting tests that I've discovered in a project called Nerd Dinner. This is an open source project, would you believe it? And it's an example of ASP.NET MVC, so an early example. So I want you guys to tell me what's wrong with this test. I know I told you it's disgusting, but why? Anything? Yeah.
Yeah, the simplest implementation is return true and it's valid.
The simplest implementation is return true, so what's the problem?
Well, that's what I would do if I do test-driven development and
Yeah.
I have a green bar.
That's true. But is valid, just so you know, it's built into the framework. There's like a trillion validations that you create custom validations. This is part of the base class. This calls your validators. So, yeah.
What's the correct properties?
What's the correct properties? What the hell is all properties correct? Yeah, that's the beginning of our investigation into this as we try to understand what the hell is going on. Dinner should be valid when all properties are correct. This is an example of what happens when you try to test many things at the same time. The test name has to be very, very generic. Okay? Are these really all the properties? What's correct about them? What's correct about USA? Is it that it's uppercase? Is it that it's exactly 3 letters? Is it it's less than 5? What's correct? What's correct about this? Does it always have to be Scott Goo? Is this the correct thing? The thing that's here? What's correct about this? And of course, a lot of magic numbers. What the hell is minus 92? Where did that come from? What's correct about this? Okay? Now, you can see that the fact that they added arrange, act, and assert to the comments didn't really help the readability, right? It's an example of how putting plasters on tests doesn't make them better. Sometimes you just have to shoot the horse and rewrite it, okay? So this is an example of a test that's testing 1, 2, 3, 4, 5, 6, 7, 8, 9 different validators. For each one of these validators, you should have at least 1 or probably 2 tests. One the test that it breaks when it should, and one the test that it doesn't when it shouldn't. And each one of them should have its own good name, and each one of them should run separately. Because if this test ever fails, how do I know which of the properties actually failed? Nobody knows. So now I have the same thing. It's like multiple asserts all over again. I don't know which one of these is the important one. Okay? Questions? So don't use that as an example of how to write a test. Use that as an example to scare your children if they ever try to write unit tests, and tell them how not to do it. So that's more of the, we started with trust and then we moved on to readability. Let's talk about maintainability. One of the best ways to maintain maintainability is to not to test private stuff. But there is a bigger notion behind this. Because I used to teach this and I used to say, well, don't test public methods because private methods tend to change. But then I realized that there is a bigger thing. Do you want to stop for a second?
No.
Okay. There's a bigger thing. What does unit testing mean? And I gave it a thought and I said, sometimes a unit in a unit test is a method, sometimes it's a class, sometimes it's actually multiple classes. As long as it runs in memory and it's repeatable, doesn't have dependencies, I treat it as a unit test. So what's a unit? A unit for me is a unit of work. It's a small use case in the system. It always starts with something that's public, some public API. And it has 3 types of end results that you can notice from the same level of the initial API. The 3 examples of results from a unit of work could be a return value. You call a method, you get back a return value. That's 1. But sometimes you call a method and it's void, it doesn't return anything. But it still does something, right? You add a user to the system in memory. So the method doesn't return anything, but it adds a user to the system. So there is a change to the state of the system. Now the way you test that is that you test the behavior of the system changes. So there is a noticeable change to the behavior of the system if you add a user. Maybe before you couldn't log in, and now you can log in with user details. That's an example. And the third type of unit of work result is that when you call a third party, when you call a logger, you call a web service. There is no change to the state of the system, you just forward a call somewhere. Sometimes invoking one method has 3 end results at the same time. But each one of them will have their own separate test. Because each one of them is a requirement. Each one of them needs to fail separately. And you still want to know that the others are running and passing. But you'll notice I haven't said anything about private methods, because a unit of work always starts with the public method. Because that's where your use cases start. They don't start with private methods. All private methods exist in a universe where they have to be called by someone that's public. Okay? There is always a public method that starts something that's private. So if you have a private method that nobody calls, does it really make a sound, etc.? No, private method always exists in the context of some public something. That's where you start the test. That's where the use case actually starts. Because if you test a private method directly, even if it works, it doesn't mean that your code is doing what it should. If you invoke a private method that's supposed to parse a phone number, and the private method successfully parses the phone number and returns to you whatever is needed, it doesn't mean that someone is calling the method correctly. It doesn't mean that whatever the results of that private method were actually used as a result that's meaningful to some user. And so a private method is just an implementation detail. A unit of work starts with something public and ends with something that's noticeable. A return value, an exception, change to the state of the system, or a call to a third party. There's always something that's noticeable. And if you test the private methods in the beginning, in the middle of it, what you're doing is you're actually just saying, forget about what's actually, if the user is able to log in, can I parse the number? And that doesn't make any sense. Because you can always parse it correctly, it doesn't mean you actually use it. So in test-driven development, I try to start with the public APIs, and I don't have any private APIs. Maybe later I refactor to create private APIs, I don't care. Because they will already be covered by the public stuff. That's why when I have properties, a person.name, a person.age, that's not something that I try to test separately. Because the name and an age will be used as data in one of the use cases, in one of the many use cases in the system. So I'm not worried about testing a property, or getter or setter. That doesn't have any logic, it doesn't make any sense to me. But what I will be testing is that given a person with these properties to a system that looks like this, I get back a value, or I get an exception, or the system state changes, or a call to a third party is made. That's when I know that it actually matters that the person has an age or a name. To maintain tests, you have to be able to maintain code, and tests are just regular code. So in a way, whenever you have tests that create the same object multiple times, if tomorrow you add a parameter to the constructor of that object, now you would have plenty of tests that don't even compile. Now we have to go and fix all of them. So one way to avoid that is to create factory methods. Now, to create factory methods, one of the things that I wouldn't use a setup or a teardown or before, because that's usually, you have to make the test readable in two places now. I would rather see a factory call in the same method. Let's see if I can actually show you a small demo of that. Hey, Windows installed new updates, thanks. String calculator tests. This is an example of a kata called string calculator that I created. This is an example of the simplest test that I can write for a string calculator. And you can look at the name of the test here. So add is the beginning of the unit of work. That's where the unit of work starts. That's the input, an empty string. And the third part is the return value, or the state change, or the expected behavior, or a call to a third party. So the name contains three parts, but then to get the string calculator, I don't initialize it in some setup method. I can see directly that I'm creating a new one. So when I read the test, I don't have to look in multiple places to understand my test. That's a very important thing. Because if I need to look in two places, then I'm already annoyed. And I try to get as least annoyed as possible, because these tests have to last 10 years. You'll also notice that I have a separation of empty lines between arrange, act, and assert. So I don't have to create comments for it. I can always tell that the last part is the assert, the part just before it is the act, and the part just before that is the arrange. And if we scroll down, you can see that the tests kind of look the same. This is an example of parameterized tests, where you can actually send multiple parameters to the same test. but the parameters are hard-coded. They're not dynamically created. So there is no chance of logic creeping in. But they're all using makeCalc. There is no setup method here. There's also no teardown method unless I have specific things that I need to reset. For example, static stuff. I would venture to say that if you have a teardown method or an after method in your tests, you'll most likely have integration tests because you have to clean up file system stuff or configuration. The only time where that doesn't make sense is you have to clean up static singleton in memory or something like that. But usually a teardown is a sign of complicated tests that actually have to clean up after themselves. Are there any questions so far? Okay. So what we're going to do, we're going to take a 5-minute break. We're going to come back after getting some coffee, and then we're going to talk more about maintainability and readability. We'll finish up with some Q&A. Okay? So 5-minute break. I'll see you in a minute. Okay. So in the previous part, we started speaking about maintainability, and I showed you an example of a factory method. When sometimes I would also create these methods for configuring an object to a specific state. If I see that I have more than 2 tests that need, let's say, a calculator that has been invoked 3 times, I would create one that says init calculator to be used 3 times. I would extract just that portion to a helper method. And the reason is, if you see multiple tests doing the same thing, it's probably some kind of use case in the system where something is in an invalid state, or there are specific versions of an invalid state. And if tomorrow an example of that invalid state changes, you have to fix a lot of tests to do it. And the last part is that sometimes, if you don't have an ability like test case in your test framework, for example, I know that I'm pretty sure that in JUnit you cannot do this. But in NUnit, in .NET, you can actually create parameters descending to the tests. And then you can actually share the test code. But if you cannot do this, you have to extract this and actually make a helper method called, like, let's say, verify single number. And then have single line unit tests that call this helper method with these parameters. So each one of them would actually be a separate actual test case method when you don't have that ability in your test framework. If you want your tests to be maintainable, they have to be fully isolated from each other. For example, you cannot use a test that calls other tests. I've seen people do this, and they usually try to do it because they want to use the same piece of logic that's already implemented in a specific test. But instead, just extract a method and call that method from 2 different tests. So all tests should be able to run alone or together and always return the same thing. The worst thing you can do is to have tests that only return that only fail in specific times or in specific cultures, etc. So whenever you have that, you have to fix it immediately, and you probably have integration tests when that happens. The only time when you don't is when you have some kind of shared data source. So it could be a static singleton that everyone shares. It could be a database that everyone is using, and so they affect each other. And I said multiple asserts before. Here's an example. Multiple asserts on different objects means that you're testing multiple things, different things, in the same test. And then you would want to separate them into multiple tests. Because if one of them fails, you'll never see the other one run. So it's like a doctor that's seeing a patient but only hearing half of the symptoms in those, and then they still have to fix the problem.
Question, small question.
Yeah.
In JUnit or for method, we used to have verify or validate, in which your test didn't stop, get here, it gave an error, and then continue to iterate to the next test. Is it not?
Well, I'm pretty sure that it still throws an exception when the validate doesn't work, so it's the same.
But it didn't stop the testing. It didn't stop away, It didn't throw the exception and then stop away.
If it doesn't throw an exception,
It
then that kind of negates that problem. But I've never seen any validation methods that don't make the test fail on that line. But if there is one, though, I have something to learn, obviously. I would love to see that, yeah.
I've heard this many times, but I don't really understand how is it hurting me? Because what I'm looking for is, if it fails, it fails. I
Yeah.
probably changed something in the last 10 lines of code I wrote.
Yeah.
So that's where I'm going to look.
Okay.
Uh,
So how does it hurt you? So the question you should ask yourself is this. If this fails, do I still care if this fails or passes?
Of course.
no, not
Sometimes
right now.
yes, sometimes. Now, if it's the same object, if you're testing person name and then age and then whatever, then probably it's the same object. One failed, you don't care about the others. But this here, you're asserting that some result is true, and also some other method under test is returning ones. These are two different things. This still, you want to know if this happens because this is a separate thing.
It cost me one more run of the test.
It could be actually much worse because if you don't know if this passes or not, and you fix this, if you had known that this fails as well, you would fix a different place. But maybe because you fixed the wrong place, now there's a new function, there's a new error here, or you realize you fixed the wrong place and then you have to go and fix it again. So the more you know, the better. The less you know, the worse off you are. And now it doesn't. It's not like we're printing this on pages. It's not like it's costing us trees to extract a method here. It's just another 3 lines of code, really. So it shouldn't be a problem to extract another test case. Sometimes, yeah, you think, oh, it's just another method. But it only takes one test. Let's say that it doesn't hurt you for a year, and then next year something happens and you realize this. You say, I should have done this a year ago. You only need one test that hurts you really badly, that you realize, oh, I was on a wild goose chase, trying to fix this, and I broke this, and then I broke the other. If only I had seen that 3 of these fail and 3 of these pass, I would go directly to the source where I know that something that affects all these things is true. But instead I fix it in a different layer. So it's about knowledge, really. If you really don't care about this one when this fails, then you shouldn't extract another test case. Okay?
I guess
Yeah.
for me it's a lot about communication. So the test should communicate something that this is what we are testing. And if the asserts aren't related, then it doesn't make sense.
Yes, it's definitely about communication. So what's your name?
Rasmus.
So Rasmus said it's about communication. It's about that multiple asserts communicate what the intent was. And if you have multiple asserts that don't relate to each other, then it makes it less readable. And I fully agree with that. You want to make things readable, and the test name should actually tell you exactly what's supposed to happen. I don't even need to read the asserts if I have a good test name. If I have a good test name and I see the asserts and I get confused, then something is wrong there. Here's an example of multiple asserts from real life. Do you see it? So this is basically an array of delegates, of basically anonymous functions. Each one of these, it actually has a new object that doesn't have a name. And it has 2 properties, a property named parameter with this value, and a property named action, which is actually an action that calls HTML helper route link. Now, so we have 1, 2, 3, 4, 5, 6 different objects. Each one of them have the same parameter value, but have a different overload method call. So route link has 6 different overloads in this library, and each one of these lines calls one of these overloads. Why was all this work done? So you can have this loop here. For each testing tests, exception helper dot expect argument exception null or empty. So basically, it's running these actions through loop and expecting that an exception is thrown. Okay? So basically, again, I keep saying the word basically, so that's basically not okay. I'll try to avoid that. So originally, they intended to just run one method and say, if I call HTML helper route link with a specific value like string empty, I get an exception. But then they said, oh, the overload, this looks exactly like the same test. This looks exactly like the same test. So let's just group them into a loop and run them. Engineering-wise, this is a great idea because it almost looks beautiful. But test-wise, this is not a smart idea. Why? Any ideas?
Because the first one that breaks won't show if any others break.
The first one that breaks, you won't see all the other results. And each one of them is actually a different method. So each one of them, you care to know if that specific method overload breaks. Each one of them is a different concern. It's a different test. Even though they almost look the same, they're not. So you run this loop and this one breaks the loop, you never see these overloads run. You never know what's going to happen. Yes, break it up into 6 different tests. That's okay. The world will not burn if you do this. Here's an example of another thing you should avoid of having multiples of. You probably can't see that. So let's start. This is let's start with this test name. Okay. Does anyone want to read this? Yeah, very readable. Anyone else want to read that? I'll try. Execute core with a synchronous invoker in action complete successfully. So that's a very verbose name. It obviously tells us a lot of information, but it's very, very confusing. It's really hard to parse this. Now, I really like it when I separate these things with underscores so I know what's supposed to be each part, but you don't have to use it. But sometimes when you don't use it, you get stuff like that. I'm just saying. So, but this is not the big problem in this test. The bigger problem in this test is I look at the bottom of the test and I see these two things. I say, okay, that's already a problem. I don't care what this test does. There is already a problem here. A verify is a sign of using a mocking framework or an isolation framework to assert that some method on some object was called. But here we have 2 objects where we verify that they were called. And that's another symptom. There's a variation of the multiple asserts symptom. Because basically each originally each mock object is its own concern. It should be a separate test. Because it's another end result. A mock object is an example of a call to a third party, which we don't control. A fake logger, etc., a fake web service. So mock objects are used for that third type of unit end result, where it's not a state change and it's not a return value. It's calling a third party which we do not control. So we fake the third party and we assert that it got called. But here we have 2 third parties that got called. So something's wrong here. It could be that these 2 are really important, and then what I should have here is 2 different tests. One that asserts this, and one that asserts that. And then I would be happier. But, look at the name of this test. It ends with the words, completes successfully. What does complete successfully mean? Nobody knows? What do you think it means?
It doesn't throw an exception.
Doesn't throw an exception. Doesn't throw an exception is complete successfully. So why do they have mock objects in the first place? Maybe they shouldn't. Maybe they just want to prove that something executes and doesn't throw an exception. So sometimes maybe they want to prove that some mock object was called, but look at the name of this mock object here. We have a mock invoker. That might be something that makes sense as a mock object because we want to prove that an invoker got called. But then we have a mock temp data provider. A provider is something that inputs something into the system. It's not a third-party system, it's a provider. It's like a database. Database is something we use to get info into the system. Sometimes we save things to a database, but it's not going to be called just a provider. Temp data provider. It's a data provider. If we look at the test, we'll see that there is something called a temp data provider here. We tell it to expect load temp data and save temp data. And it returns some dictionary. And it has to be called at most once. So we're expecting 2 things, that it called load and it called save. Save is an example of a system that saves something outwards. So it calls a third-party system, saves an information somewhere, and that's an end result. But loading temp data is not something that you call and you forget. It's something that you get from something. It's like a stub. It's something that inputs information into the system. But we're asserting that both this got called and that got called. Sorry, this one and that one. But then we also assert that an invoker got called on whatever these two methods here. So both these things are important. They should be separated into a different test. Sometimes we don't actually care about actually temp data. And I would argue that in this test, this shouldn't be a mock object, the temp data provider. It should be used as a stub to return fake data into the system, but we should not verify that it saves, that it actually got called. If we do, we have to separate it into a different test. If we are not domain experts, we can't really tell. But we can certainly tell, regardless, that if I see two verifies, that's a sign that something is wrong. That you're probably asserting on multiple things. And you probably want to change the name of your test to tell you exactly what's supposed to happen. So I hope that doesn't confuse us too much. That's a pretty complicated test. Questions? Yeah?
There was, but in certain situations, we have to accumulate some similar kind of test in a single test, to say a few milliseconds when we're in thousands of tests.
So I'm not sure I understood the question. In certain situations, you have to write tests where
You have to write multiple assertions or multiple verifier, which are more or less similar, just like if we're using the same object. So we can ultimately some few milliseconds if we're running thousands of unit tests.
So sometimes you want to assert multiple things in
Yeah,
the
of
same
course.
test to save milliseconds?
Yes, of course.
Well, first of all, it's not going to save you those milliseconds because those things are still going to get called. It's not like you're doing less actions. Running those tests, running an extra test, is such a small cost compared to anything you'll ever have. Is that what you lose because of it? It's much worse. So imagine that you saved 10 milliseconds over a day, but you lost 10 minutes
10 minutes.
to understand the test. Okay? So it's not worth it. I've almost never seen a performance issue with tests where you didn't have much bigger issues in the tests themselves that you wanted to solve first. I would rather have slow tests that are readable than fast tests that no one can understand. Okay? And I've seen systems, I'm sure you guys have too, where you have these amazingly maintainable tests where you have a base class of a base class of a base class, and all these tests are just one line of code. And you want to add a test, you have no idea where to start. And why does something happen? So information hiding just to make maintainable or performant doesn't actually help. It actually hinders. So test code is not regular code in the regard that always maintain performance-wise it's important. Readability is much more important. Okay, so let's talk about readability, and then we're going to finish for today. And maybe if we have time, I'll do a little song. I know that sounds weird, but that's life. Readability comes from structure. I want to be able to find my tests easily. So a naming convention is really important. For example, here we have a naming convention of the production code, and then a folder of tests with test.the name of the project. Sometimes I would just use the name of the project dot unit tests, the name of the project dot integration tests, and I wouldn't even have a folder like tests. It doesn't really matter which naming conventions you choose, as long as you choose one and you are consistent about it. So looking at a project, looking at a method, I should be able to determine where the tests for this method exist. Bad naming. You want tests with bad names, that's very easy to generate. Here's an example of a real test from ASP.NET MVC Nerd Dinner. Someone taught someone test-driven development, and this is the first test they wrote. Register get. Create a controller, called controller register. Okay. Has nothing to do with anything. You get a result, and then you check the view data of password length. And of course, the name suggests that we should maybe just not get it all. probably the right assert here would be to assert that we're getting a non-null. So where did the 6 come from?
Trial and error.
Sorry?
Trial and error.
Trial and error. Well, actually, the 6 is somewhere hidden in the system. But what happened, of course, in that system, you're going to have hundreds of tests with 6. And there are hundreds of tests with the number 6 there. So magic values. You want to get rid of magic values as much as possible. This and this are the same test. Okay? Don't just use the numbers. Give them actual const names that I can actually read, like a book. So the 6 came from, can you find it? Somewhere there is a mock membership provider, which is actually, we should call it fake, but I have like a whole day just on the difference between mock, stubs, and fake, so if you're ever interested, let me know. But here, someone overrode the minimum password length and just said 6. So there you go. So then all over the system, people use 6, and now you have to look for it. There's like a hidden protocol. Here is something even worse. Someone overrode create user in a fake membership provider and said, look, if the username is some user and the password is good pass, and the email equals email, then return a membership create status of success. Only if these values are true. No one can ever know this, because it's not written anywhere. It's not like consts. So someone who writes the test has to use these values. But if someone wants the membership provider to simulate a problem with the membership status, then they should create the email parameter in the user that's created should contain the name of the enum of the membership create status. So there should be some kind of string in the email field that is actually the name of an enum of the membership status. And based on that, it will try to parse, the enum parse, from the email. So imagine this is called a hidden protocol. I call it hidden protocol. You want to create a user, but you want to fake the creation of the user to not succeed. How do you do that? There is no way for you to know that. You have to find the elders who created the original tests 5 years ago and ask them, how do I do that? Because you will never, no one will ever find this code. It's hidden really, really well. Okay, any question? Okay. So magic numbers can appear, but they can also disappear. They can also hide from you. And then you'll see tests where the email of the user is membership status dot invalid. Here's an example of a magic value. Can you find it? Checking is not magic. 15 is magic. What the hell is 15? Where did 15 come from? Is it the number of methods in a class? Is it the number of characters in a string? Is it the number of seconds that are supposed to pass between the test? Nobody knows. No one will ever find out. But it prevents me from understanding the test, so it just wastes my time, wastes my brain cycles on understanding something that's probably not important. I don't like it when people waste my time. Call it what it is. I don't like to call things mock on the class name. I like to call them fake. Because a mock is a specific word that tells you that you have something that you will assert against, something that will verify calls against it. But a lot of times we use these classes just to return value into the system, and we never assert against them. So I like to call them the fake principle, and based on how you use them, if there is a test that asserts against them, then in that test, the variable name for this object will have the word mock on it. So everything that you don't assert against that looks like another object is a stub. If you assert against it, it's a mock. Otherwise, it's a stub. This is just a pet peeve of mine. Everything in the world is named mock, but maybe 5% of the things in this world are actually verified against. So they're actually stubs. And you want to know the difference between mocks and stubs because you should have no more than a single mock object in a test. Because if you have multiple mock objects in a test, you actually have multiple asserts on different things in a test. So you should know the difference between a mock and a stub so that you can review other people's code, so that you can find these problems. If you don't know the difference, you'll never find this problem ever again. And then you'll just go through life with pain and suffering. Your time will be wasted. And finally, naming. Now, I find that this naming convention is really helpful if you're new to unit testing, because it reminds you of the 3 parts that each test name should have. It should have the unit of work, it should have the scenario under which you're testing it, and it should have the expected result, either a return value, or state change, or a call to a third party. This is an example of a return value. Exception is something that's returned to you. As you get better and you get more confident, you can change to different naming convention. You can use things like RSpec naming convention, where you have nested, given, when, then. But you'll always have these 3 parts somewhere in the class name. You should. Here's an example of the Jasmine framework in JavaScript. Okay. In the Jasmine framework in JavaScript, you can have describe. See this? Describe is, in our case, the unit. And then underneath, there's another nested describe. And this is the scenario. And then there are multiple end results. It should create a list element, and it should have a class of to-dos. So there is 2 state changes here. Now, this is not someone who knows my naming convention, but tests that are readable will ultimately contain 3 parts. The thing that you're testing, the scenario under which you're testing it, and what the hell is supposed to happen. Sometimes you have multiple things that's supposed to happen. Now, frameworks like this, RSpec-based framework, I call them, can have multiple its. And the nice thing about it is that each one of them is an assert that can fail, but you'll still see the others. So they're great when you have a single point of entry, but multiple end results. But always remember to have these a nesting of the unit, and only then another nesting of the scenario. Okay? So to-do list view, when you instantiate it, should create a list element and should have a list of class to do. If I was using a regular naming convention, I could still write 2 different tests that have these 3 parts. They just live in different areas. Okay? So you'll find them regardless of the naming convention you use, but make sure that you don't forget each one of these 3 parts. I also usually like to separate the assert from the action. So I don't like a very, very long line. I would like a line that's separated, then I can assert against it. I once saw a test that there is an assert is true, and then a long line that says assert is true, blah, 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 equals false. But that's at the end of after the end of the screen. So if you never read to the end of the line, you assume that something is supposed to be true, but it's actually supposed to be false. So that sucks. So that wasted my time a bit. So that wasn't nice for the person who wrote it. So make sure you can, it's less cluttered, you can then use the result if you need it for something else. But these are simple rules for readability. If you are writing tests that have multiple inputs and you're doing test-driven development, you're going to find that the inputs that you want to input all the time between test and test, they change very, very slowly. So there's very small changes between test and test in the inputs. Make sure that if you send multiple inputs that they're different from each other, because sometimes the order of the parameters is important. If you send in the same parameter values, you might actually not find the bug, because maybe one of the parameters is used and another one is forgotten. So you always want to make sure each parameter is being tested separately. Also, if you're sending the same input, make sure that between tests, the reader can see differences from one test to the other. And when the reader can see one test to the other, and they can see a pattern, they can see actually how you wrote the code. They can see how your mind worked when you wrote the code. If you see, oh, 1 and 1, then 1 and 2, and then 10 and 20, and then 100 and 200. they can see a pattern between these tests, and that's a great thing. And those are the three parts: readability, trustworthiness, and maintainability. Are there any questions? What are your questions? Okay, so, yeah?
I have so many questions, so I'm
So
almost
many.
afraid to waste time.
Do you have, what is your favorite one?
Well, actually, maybe we should take it afterwards, because I would like to show you actually some of my C++ unit test code and ask you
Sure.
what I'm doing
I
wrong.
usually try not to watch C++ after 7,
Yeah.
unless I have a good bottle of vodka next to me.
Yeah.
But I'll try anything once.
Excellent.
I also, if
Hello?
yeah, you had a question.
So how can we tell when a test is testing too much?
How can we tell when a test is testing too much? Well, there might be multiple signs for it. First of all, the name would be very, very generic, because it would be hard to give it a very specific name. And then you can just look at the list of asserts and see how many objects are being tested. If you're testing on more than a single object, you're usually testing too much. If you have more than a single mock object, you're testing too much. If you have a mock object and a regular assert, you're testing too much. Should be separate tests. Those are the clues that I usually go by. If you see a test that's 2,000 lines long, you're testing too much. Okay, so anything over 1,500 lines is probably bad. Okay, probably anything over 15 lines begins to smell a bit. Okay, other questions? Yeah.
If you work in a small software company who uses very little unit testing and do not use TDD, if you want to start use TDD in that company, how would you do it?
How would you start to use
How
TDD
would you,
in the
like,
company?
for example, how would you do the change? So people who have never ever used TDD before,
Yeah.
who are scared of it or like have some kind of resistance using it?
Yeah. That's a big question, because that's not an easy thing, but it really depends on many things. What is your role in the company?
I'm a developer.
You're not a team leader,
No.
so it's going to be much more difficult for you to convince people.
Yeah.
I would, well, it's a whole separate topic, but
Yeah.
just so you know, I would, in my book Diary of Unit Testing, I have a whole chapter on how to convince your organization to get to do unit testing. So there's a lot of tough questions and answers. It's just a whole topic about this. And in the second version, I'm adding a whole new section to this topic. And in that section, I talk about influencing other people. And I talk about the fact that for each behavior that we see people do, the world is perfectly designed for that behavior to happen. The world around that person is perfectly designed for that behavior to happen. And it's from a book called Influencer, The Power to Change Anything. And what they talk about in the book is that when we try to convince people, we usually look at only two factors. We look at the person's ability to do something and their motivation to do that something, their personal motivation. And we think, okay, if we clear those two, everything's great. But we don't look at 4 other factors. Socially, we don't look at the social motivation and ability of that person to do something, whether they're the only one trying to do it, or maybe there are people they respect that don't want to do it, so they convince them not to do it. And environmentally, we see that maybe there are rewards and punishments to do a behavior. Mike Cohen has a great book called Succeeding with Agile. And in that book, he explains that he was explaining pair programming to a bunch of people, and one of the people got up and said, "I'm not doing this," and just went. And he started to investigate why that happened. And that person explained to him later that he gets a yearly bonus based on the quality of the code that he wrote. But if he was doing pair programming, you wouldn't be able to tell which code was written by him. So he would actually get paid less if he was doing pair programming at the end of the year. So that's an example of environmental rewards and punishments for specific behaviors. Until you change that environment, you're not going to be able to get the person to change. And the last one is environmental physical ability. people want to do pair programming, but all the tables are these round tables where there's only room for one person to sit. So no one can actually do pair programming. People want to do unit testing in TDD, but no one has the budget for a build server. So you're already screwed. It doesn't matter how much everyone wants to do it. Okay? So there are 6 factors that you have to look at to understand why someone is doing or not doing something. And if you want to fix these factors, you have to change everything between those. Maybe 3 of them will be problematic. You have to change all 3 to get the behavior to change. If you just change one, nothing's going to change. So there's this whole science behind influence that I've been learning in the past few years. And it's very, very interesting. So I would look at that if I wanted to change people's behavior. And lastly, I would recommend that you look at the book called Becoming a Technical Leader by Jerry Weinberg. And this book explains on how to become a leader that changes the thought of other people by becoming a problem-solving leader. It's not an easy book, but it's really, really recommended. I hope that answers the question.
I'm sorry, but we have to leave because we're going with the train back to the countryside.
That's okay. The song will have to be recorded without you.
Yeah.
Thank you, great talk.
Okay, thank you. Hi, Dol.
Hello.
I know.
The other question is quite similar, but at 2 occasions I've been a part of projects as a front-end developer. It's my role, and when we have discussed TDD as a part of projects, both of these times it has been taken off due to financial restraints and because the customer couldn't afford it.
Yeah.
How would you? And maybe I mean it's my question is kind of how would you how would you make that not happen? Like show the how can you more clearly in a small scale project show the benefits? Like
Yeah, I understand.
as a project manager or as a maybe a UX lead or something like that, because usually those are the ones who have customer relations.
So, yeah, I'm trying to show you something here. Let's see. This one done. Let's try it again. Yeah. So I have the special slide for that. This is usually what I tell people, especially when I talk to managers. A few years ago, I was involved in a project for a very big billing-related company, about 5,000 developers. And in that billing company, we had 2 different teams. One of the team was actually being coached and consulted for by me for a couple of months, and we were teaching them TDD. And both teams at some point had the same task with 2 different customers. Take an existing feature and adapt it to a specific customer's needs. So when they were required to do it, we realized it was almost the same task. So we used the opportunity to measure the differences. So this was the team that was not doing TDD, not unit testing, nothing. They were just doing regular because we were just doing 1 team pilot back then. And for a specific implementation, it took them 7 days versus 14 days for the team doing TDD, almost half. But then we saw that the process was actually much longer. We had the testing and fixing, and already in the testing and bug fixing phase, the testing and bug fixing was much faster because they were not only finding less bugs, but fixing the bugs was much faster. Because when you don't have tests, you fix a bug, then you create new bugs. But here it's much easier to not create new bugs without finding them. So at the end of the testing, the release actually took only 3 days more with test-driven development than without, for about a 3-week release. Even though the implementation took about double the amount of time. So the big question is, what did they get for the 3 days? And what they got for the 3 days was pretty incredible. The amount of bugs found at the customer side was 90% lower. 90% lower than the other team. So the customer was happy. The team was pretty happy because what they found was that they really felt like they had a safety net for the past and for the future. So when they introduced new people, they not only had API documentation to understand the code, because the tests were written in a very readable way, but they also had this ability to start changing the code and see what happens, like a big what if. So they could optimize, etc. So for 3 days, I don't know if any manager would say no to that. Now, when I teach this in classes, a lot of people usually say, well, that's not a process in our project. In our project, we have one extra step at least. In our project, we implement stuff, but we also have to integrate with other projects. And truly, what actually happened was, when I saved a surprise for last, is that in that team, since it was such a big product, they also had integration with other modules and other projects. And what we found was that the integration for the team without TDD was actually much longer. They would call it Hell Week every time that happened. That's the week where nobody sleeps, everything is like a coffee spill on the floor, and everyone just get this thing out of here. But here it was kind of a nice 2 days where people would just, this failed. Let's see what happens. Oh, it's not here. It's probably a configuration issue. Fix it. Next. It's not like they didn't find bugs, but their bugs were much easier to find, much easier to fix, because the unit test covered a lot of the code. So with the time saved here, it actually took the team with TDD less time to release than the team without. Even though initially the implementation, the coding, took double the amount of time. And what's hard for managers to see is that the implementation is all they see. They don't see the bottom line, because the bottom line often comes a few months later. And that's not good enough, because it's really hard to see. So TDD is really a long-term investment that's very hard to convince managers. So other than using these anecdotal evidence, there isn't a whole lot except that I know that works, except actually doing it and showing after the fact. Now, it's not like you're not supposed to do it anyway without telling them. I believe that you're like a mechanic who fixes someone's car. The mechanic doesn't call you and ask, hey, do you want us to do it good or bad? If you want it bad, we can do it in half the time. They don't ask me that. They just tell me it's going to be 6 days and that's it. And I say, oh, screw this, but what am I going to do? And that's life. So I estimate my tasks with unit testing included. I don't say I'm going to do unit testing because it's implied. This is the way I work. It's not like when I sell you a car, you get to choose with or without tires. The car comes with tires. I just say it's going to be created and this is the time it's going to take, and that's it. It's not an a la carte where you can take unit testing out. Just the way I work. And maybe at the first project it's going to feel weird, but that's the way it is. And that's what you get paid to do, is to do good work. So I hope that answered that question. Other questions? Okay. So with that, what else do we have? So with that, I would like to do a little song for you guys. Just because you came all the way. It's the first meetup for Bouvet in Sweden. But for this song, I would actually need a volunteer. You don't have to sing. I just need someone to press space so everyone can see the words of the song as I sing it. And if you need any special encouragement, I'll give you a free version of my book. Just for doing it. There it goes. Okay, what's your name? Mosi. Mosi? Can you give your hand for Mosi? So first of all, don't touch anything. I'm going to teach you everything you need to do. Okay? Have you ever pressed space before? Should be okay. Okay. So, not my guitar. Already broken? Seems legit. Okay. We're going to do a little test for you first. So every time I finish the words on the slide, you press space.
Thank you.
Okay? You ready?
Yes, I do.
This is a test line. Oh, so it's time for a song of mine. My mistake, sorry. Okay, now we're gonna start, sorry. I forgot the test. It's test first, right? This is a test line. Looks like you're doing just fine. It's time for a song of mine. Okay. Now we can actually start. You've passed the test, congratulations. So, I wrote this song. I have something wrong here. I wrote this song based on a project I was in, and the project didn't have any tests. And no one wanted to work in this project. I'm sure I was the only one this ever happened to. It's late in the evening. I'm wondering what words to say. It's so hard to breathe here. The customer's face is gray. And then he asks me, is the product alright? And I say yes, we deploy it all tonight. I check in the changes. The code doesn't even compile. I wish I was home now. Instead I fake a big smile. And when they ask me, is the code alright? And I say yes, it seems to compile tonight. And I feel horrible because I see the sadness in their eyes when they find out that the product doesn't even have log files. This thing is due. It's time to go home now, and I've got an aching head. So I lock my computer and pray that tomorrow I'm dead. When my wife asks me, do you feel alright? I say yes, let's watch Game of Thrones tonight. I feel miserable because I'll guess the madness in their talk when they find out that tomorrow I don't plan to come to work and write my CV. Thank you. So I hope you guys enjoyed. Don't break. And I hope to see you sometime soon. And if you guys have any questions, feel free to contact me at this blog. And I'll be here for a few minutes as well. Okay? Cheers, have a good evening, and we'll see you sometimes. Vi ses!
Yes.
Ha det!
Tack så mycket. Tack.